21st of 2025, April. I'm going to do very quick TCP summary. First, what we did was there's packet switching and there is circuit switching. For circuit switching, it's dedicated link and capacity end-to-end communication and guaranteed bandwidth with minimal delay, which is continuous bit stream instead of also it is either if divided host isn't transmitting, but if we talk about packet switching, it sends data package instead of data stream. It requires routing and forwarding, has issues with delayed and lost packets, supports more users with higher bandwidth than a comparable circuit switches network. So what is important is we should calculate the probability. So there's two formula. One formula is related with circuit switching, which is Mbps by number of users. Then it will be one user's speed that they can use. But for the packet for circuit switching, what circuit switching needed is the probability of actual time that users use it in same time. So we can calculate it by NCR combination. So NC1 will be from n number of users, one number of users actually using probability. It will be like user's actual probability is 10 or then it will be 0.1 over 1 or 0.1 power to 1, and another thing will be in combination formula. And we should calculate, or there can be such problem as what is more than 10 people actually using at the same time. Then we should do 1 minus sigma from n1 to 10 NC1 to NC10. We should calculate that each one number of users, two number of users, three number of users, to 10 number of users calculate in same time. This is this calculation came out. And second thing is sequence number and acknowledge number. During handshake, TCP has handshake, so guarantee the reliable data transfer. What we do is first SYN number will becomes SYN number become 1, then sequence number will be initial sequence number. When sequence number equals to SYN number equals to 0, sequence numbers become initial sequence number plus 1. And during data transfer, sequence number equals to initial sequence number plus data length plus 1, and acknowledge number from sender to receiver and from receiver to sender, receiver's acknowledge number will be last byte received plus 1. So if they receive the data until 200, then they will send 201. Very simple. And there's also a very important issue related with sendbase. Sendbase is sender's thing. They have sendbase, and after they send it, and after they receive acknowledge number, then they will increase the sendbase again, and they will again send it. So sendbase will be sequence number that sender is sending, and after they receive it, then they will change their sendbase to acknowledge number. And there can be three cases, which is acknowledge number is bigger than sendbase, then which they will naturally update their sendbase. But if sendbase and acknowledge number is same, after they send it, and if acknowledge number come back, and if it is same, then there's some problem happen. What kind of problem happen? There can be timer timeout or duplicate ACK or packet losses. So think of the situation. Come back. Then what we should do is maybe fast retransmission, send what we sent again, or we should wait for it. And another case is sendbase is bigger than acknowledge number. In this situation, we can think of the out of order situation, like we send sequence number 92 with 8 byte, and we send sequence number 100 with 20 byte, and send. Acknowledge number 100 came, and later acknowledge number 92 came. While coming here, because of some reason, order changes. In this case, it will be y acknowledge number is smaller than sendbase. This will be kind of issue. Then we should again resend it or something. And there's also about concept related with SYN control pack, which is SYN fake things. It's related with, especially when we do first handshaking. And so if I organize what TCP solves is TCP reduce the loss by transmission, minimizing it by congestion control, and also they reduce delays by fast transmission and flow control, and they also solve out of order problem with retransmission. The related TCP things, maybe we should calculate the RTT, which is ACK time minus retransmission time, or timeout interval, which is estimate RTT plus 4 deviation of RTT, or calculate the throughput, which is R. How can we calculate the RTT? In this situation, we calculate throughput with only the last feed the last packet, because in the last packet, the receiver from sender sent, this acknowledged number shows all the data that they got. And sequence number 1 means from sequence number 1 started from 1. So we can calculate it by just divided each other. Then we will get the whole amount of data. And we will divide it by the time. Okay. Thank you very much.